I want to start differently this time, not by guiding you step by step, but by asking you to confront a situation immediately, without preparation, without comfort, because that's closer to what Europa actually is. Imagine you are already there, already beneath the surface, already too deep to turn back, and the only thing above you is 29 kilometers of ice that you will never reach in time. There is no gradual descent now, no slow adjustment, just the sudden realization that you are suspended in a place where direction has lost its meaning, where up is sealed, down is unknown, and the only thing your mind can do is try, desperately, to make sense of a world that was never built for you. You are inside an ocean, but not the kind you know, not the kind that connects to sky and wind and sunlight, because here there is no horizon, no surface shimmering above you, no sense of escape written into the geometry of the space. Instead, there is a ceiling, an endless, unbroken ceiling of ice stretching across the entire world, turning the ocean into a closed system, a trapped volume of water that has existed in isolation for longer than complex life has existed on Earth. And the longer you stay in that thought, the more something begins to shift in the way you perceive it. Because this is not just water and darkness. This is a place that has had time, immense time, to become something of its own. Now, I want you to notice what your brain is doing, because it's trying to reassure you, trying to say that this is just water, just physics, just a sterile environment defined by temperature and pressure. But that reassurance depends on an assumption that you have not actually verified. The assumption that isolation means emptiness. And that's the point where the story becomes uncomfortable, because Europa forces you to question that assumption in a way that feels subtle at first, but grows heavier the longer you think about it. If an ocean exists for billions of years, if it is stable, if it has internal energy, if it has chemistry, then what exactly guarantees that nothing has happened inside it? I'm not telling you that something is there. That would be too easy, too dramatic, too much like a story trying to scare you. What I am telling you is that you don't have a good reason to be certain that nothing is there. And that gap, that small crack in certainty, is where the tension begins to build. Because now the darkness is no longer just an absence of light. It becomes an absence of knowledge. And those two things are not the same, even though we often treat them as if they are. And this is where Europa starts to separate itself from every other frozen world you might imagine. Because most places that are cold and distant are also inactive, static, frozen not just in temperature but in behavior. But Europa does not behave that way. The surface you stood on, the one you can barely remember now from down here, is smooth in a way that suggests renewal, not decay. And that alone tells you that something beneath it is moving. Slowly, persistently, over time scales that stretch far beyond human intuition. The ice above you is not just a barrier. It is evidence that the system is dynamic, that energy is flowing, that change is happening, even in a place where everything looks still. So now you are not just in an ocean. You are in a system that has been evolving quietly, invisibly, without any need for sunlight, without any connection to the environment we understand. And that is the point where the fear changes its character. It is no longer about being trapped, although that feeling never quite goes away. It becomes something more subtle and more difficult to ignore. The realization that you are inside a place that has its own history, its own processes, its own internal logic, and you are arriving billions of years late with no idea what has already happened before you got there. And I want you to stay with that feeling for a moment, not because it is comfortable, but because it is honest. Because everything we are going to explore from here depends on it. The cracks on the surface, the forces from Jupiter, the chemistry, the possibility of life. All of it traces back to this one fundamental idea that you are now experiencing directly. Europa is not just a frozen moon. It is a hidden world, and you are not looking at it from the outside anymore. You are inside it, surrounded by its consequences, trying to understand whether this vast, silent ocean is truly empty, or whether the silence is simply hiding something that has been there all along, waiting in the dark, long before you ever thought to ask the question. At first glance, nothing about Europa demands your attention in the way a violent or chaotic world would. Because if you pull yourself back out of that buried ocean and return to the surface, what you see is almost disappointingly calm. A pale, frozen sphere marked by faint khatut and subtle color variations, drifting quietly in orbit as if nothing of consequence has ever happened there. And that is exactly why it is dangerous to trust your first impression. Because Europa does not reveal itself through obvious spectacle. It reveals itself through things that are missing, through patterns that don't quite make sense, through details that only become unsettling when you stop accepting them as normal. So I want you to look again. But this time I want you to look with a question in mind. Not what is here, but what should be here that isn't. Because on any surface that has been exposed to space for billions of years, you expect impact craters. You expect scars. You expect a long accumulated history written in collisions and destruction. The moon is covered in them. Mercury is covered in them. Even worlds with atmospheres carry their marks in one form or another. But Europa doesn't. Not in the way it should. Its surface is almost smooth, unnaturally smooth, as if time itself has been repeatedly erased and rewritten. And that absence is not a small detail. It is a contradiction, because a surface that does not preserve its past must be changing, must be renewing itself, must be interacting with something that replaces the old before it can fully accumulate. And that immediately forces you to consider the only direction that makes sense. Below, the surface is not acting alone. It is responding to something underneath it, something capable of pushing upward, of reshaping an entire world from beneath a frozen shell. Now follow those long, dark khatut that stretch across the surface, cutting through the ice in sweeping arcs and intersecting networks, some of them extending for hundreds or even thousands of kilometers. And notice how they don't behave like simple cracks in a brittle material. They curve, they overlap. They form complex patterns that suggest movement over time. Not a single fracture event, but a history of stress, release, and reformation. These structures, called lineae, are not just breaks in the ice. They are records of a shell that is being pulled, stretched, and forced to adapt to forces that it cannot fully resist. Imagine taking a rigid layer and placing it over something that moves, something that flows, something that shifts slowly but persistently, and then watching how the layer responds, how it fractures, slides, and refreezes, never quite returning to its original state. That is what you are seeing here, except scaled up to an entire moon, operating over millions of years, producing a surface that looks stable at a glance but reveals instability the moment you examine it closely. But even that is not the most unsettling feature. There are regions where the surface does not just crack, it breaks apart completely, where large blocks of ice appear to have separated, rotated, drifted, and then frozen back together in positions that do not align with their surroundings, creating a landscape that feels disordered, almost chaotic in a literal sense. These are the chaos terrains, and they look exactly like what their name suggests. Not random in the sense of being meaningless, but disordered in a way that implies disruption from below, as if the foundation supporting the ice temporarily lost its strength, allowing the surface to collapse and rearrange before solidifying again. And I want you to pause here, because this is the point where separate observations start to merge into a single, unavoidable conclusion. A surface with almost no craters, meaning it is constantly renewed, vast networks of fractures, showing that it is under continuous stress, regions of broken and reassembled ice, indicating that the material beneath can weaken or disrupt the shell. None of these features make sense if Europa is solid all the way through. They don't fit a static model. They don't fit a frozen, inactive world. They only make sense if something below the surface can move, something that can flow, something that can carry energy and exert pressure on the ice above it. And once you allow that idea to settle in your mind, the surface changes completely in the way you perceive it. It is no longer a landscape to be observed. It becomes a boundary, a thin, fractured interface between two worlds. One exposed to the vacuum of space, and another hidden beneath kilometers of ice, active in ways that are only indirectly revealed through these subtle, persistent signs. So when you stand there now, looking across that pale, cracked expanse, I don't want you to see emptiness anymore. I want you to see evidence. I want you to understand that every line, every fracture, every region of apparent disorder is not just a surface feature, but a message, a signal coming from below, telling you that Europa is not quiet, not still, not finished, but continuously shaped by something you cannot yet see, something that has been there all along, waiting beneath the ice, leaving its traces for anyone patient enough to notice. This is the moment where everything you think you understand about Europa begins to break down. Because if you take all the evidence we have just discussed and place it into the simplest physical framework, it immediately runs into a contradiction that seems impossible to resolve. Europa is extremely far from the sun, so far that sunlight barely contributes any meaningful heat, and the surface temperature remains around minus 160 degrees Celsius, a level of cold that should freeze water solid and keep it that way for billions of years without interruption. If you follow that logic carefully, then the conclusion appears unavoidable, which is that Europa should be nothing more than a completely frozen sphere, inactive, wicked, and lifeless all the way through. But the surface refuses to agree with that conclusion. And that is where the problem becomes interesting. Because if the surface is being reshaped, if the ice is cracking, shifting, and renewing itself over time, then something inside the moon must still be active. And activity requires energy. The real question is not whether that energy exists, but where it comes from, because it clearly does not come from the sun. The answer lies not beneath your feet, but above you, in the overwhelming presence of Jupiter, a planet so massive that its influence extends far beyond simple orbit, reaching deep into the internal structure of its moons. Europa does not orbit Jupiter in a perfect circle. And that small imperfection changes everything in a way that is easy to overlook but impossible to ignore once you understand its consequences. Its path is slightly elliptical, which means the distance between Europa and Jupiter is constantly changing. And because gravitational force depends on distance, that force is also constantly changing. As Europa moves closer, Jupiter pulls more strongly, stretching the moon and subtly distorting its shape. And as Europa moves farther away, the force weakens, allowing the structure to relax again. This cycle repeats continuously, not once or twice, but every orbit, every few days, over billions of years. What matters is not the size of the deformation, but the fact that it never stops. Because even a small, repeated flexing of a solid body generates internal friction, and that friction produces heat. You can think of it in simple terms by imagining bending a piece of metal back and forth repeatedly, where the material begins to warm at the points of stress, except here the scale is incomprehensibly larger. And the process is sustained by gravity itself rather than by your hands. This mechanism is known as tidal heating, and it changes the entire picture of Europa from a frozen relic into an active system. Instead of relying on sunlight, Europa generates heat internally as mechanical stress is converted into thermal energy, allowing the interior to remain warm enough for water to stay in a liquid state even while the surface remains locked in extreme cold. The outer shell, exposed to space, becomes rigid and brittle, forming the thick ice layer we observe. But beneath that shell, where the energy is being dissipated, the environment is very different, warmer, more dynamic, and capable of sustaining a vast ocean. At this point, the contradiction disappears and is replaced by something far more interesting. Europa is frozen on the outside and active on the inside. And the connection between those two states is maintained by a continuous flow of energy driven by Jupiter's gravity. The ocean beneath the ice is not isolated from this process, because the same forces that generate heat also create motion, driving currents, building pressure, and pushing against the ice shell above. Over long periods of time, that pressure contributes to the cracks, fractures, and shifting terrains that we see on the surface, meaning that what appears to be a quiet, frozen landscape is actually the visible expression of an active interior. So when you think about Europa now, it should no longer appear as a static object drifting through space, but as a world that is constantly being worked from within, shaped by forces that are invisible but relentless. The ice is not simply a barrier. It is part of a system that is continuously flexed, stressed, and renewed, responding to the gravitational pull of a planet that never lets it come to rest. And that is the key idea I want you to hold on to, because it changes everything that follows. Europa is not warm because it is close to the sun, and it is not active because of anything happening on its surface. It is active because gravity itself is doing work, because Jupiter is constantly pulling and releasing, stretching and relaxing, creating heat in a cycle that has lasted for billions of years. Without that process, the ocean would not exist, the surface would not change, and the entire moon would be frozen solid. But with it, Europa becomes something else entirely, a place where energy is hidden, where motion exists beneath stillness, and where an ocean can survive in complete darkness, sustained not by light, but by the quiet. persistent force of gravity. Everything we have built so far leads to a kind of expectation, almost an intuition, that if Europa has a vast ocean beneath its surface, and if that ocean is being kept alive by internal heat, then there must be some way for the surface and the ocean to interact freely, to exchange material, to form a system that feels open and connected. But this is exactly where the story turns, in a direction that is far less convenient, because when we look more closely at the data, especially the measurements from more recent missions, we are forced to confront a reality that makes Europa both more fascinating and far more difficult to understand. The ice shell is not thin, it is thick, on a scale that fundamentally changes how you should think about everything beneath it. Because we are not talking about a few kilometers of fractured ice that might easily crack open, but about an average thickness of roughly 29 kilometers. A barrier so large that it separates the surface from the ocean in a way that is both physical and conceptual. If you were standing on Europa, everything we have been discussing, that entire hidden ocean would be buried beneath a layer of solid ice nearly 20 miles deep. And that distance is not just a number. It is a statement about isolation, because a barrier of that scale does not easily allow exchange. Now I want you to consider what is happening at the surface. Because Europa does not exist in a gentle environment, it sits deep inside Jupiter's magnetosphere, where high-energy particles are constantly accelerated and directed toward the moon, bombarding the surface with radiation at levels that are extreme even by space standards. This radiation does something very important and very destructive at the same time, because it breaks apart water molecules, alters the chemistry of the ice, and creates reactive compounds, such as oxidants, that, under the right conditions, could serve as a source of chemical energy. In other words, the surface is being chemically processed, continuously modified in a way that could, in principle, provide the ingredients needed to support life. But at the same time, that same radiation is also tearing apart complex molecules, preventing delicate structures from surviving for long, and effectively sterilizing the outermost layers of the ice. So you end up with a strange duality, where the surface is both a potential supplier of energy and a hostile environment that destroys the very things it produces. And now you have to connect that with the thickness of the ice, because if those chemically altered materials could somehow travel downward, if they could reach the ocean below, they might provide exactly the kind of energy source that life could use in the absence of sunlight. That possibility is one of the strongest reasons Europa is considered a candidate for habitability. But when you place that idea against the reality of a 9-kilometer thick ice shell, the question becomes much harder to answer, because transporting anything across that distance is not simple, not fast, and possibly not efficient enough to matter. The evidence we currently have suggests that the connection is limited. Measurements indicate that while the upper layers of ice contain cracks and small channels, these features do not extend deeply enough to reach the ocean, remaining confined to the near-surface region, perhaps a few hundred meters down at most. That means the ice shell behaves differently at different depths, with the upper portion being fractured and dynamic, while the deeper layers remain more stable and intact, forming a long-term barrier that isolates the ocean from direct interaction with the surface. And this creates a kind of imbalance in the system. Above the ice, you have radiation driving chemical reactions, producing potential energy sources, but also destroying organic material. Below the ice, you have a vast ocean, stable, long-lived, and potentially capable of supporting life, but possibly cut off from the very processes that could provide it with energy. The two regions exist within the same world, but they are separated in a way that may limit how much they can influence each other. So when you stand on that surface again in your mind, I want you to feel that separation, not just as a physical distance, but as a barrier between possibilities. Beneath your feet lies an ocean that could be habitable, but it is hidden behind kilometers of ice that do not easily yield. Above you, the surface is being constantly reshaped by radiation, generating chemistry that might be useful, but also destroying anything fragile enough to resemble life. Europa, in this sense, becomes a world divided, not into simple layers, but into regions that may not communicate as freely as we would hope. And that tension between what exists and what can interact is what makes it so difficult to answer the question we care about most, because it is not enough for the ingredients of life to exist. They must also come together in the right way. And the ice between them may be the very thing that prevents that from happening. And that is why the thickness of Europa's ice is not just a detail in the story. It is one of the central obstacles, a frozen barrier that holds the most important part of the moon just out of reach, preserving its secrets while forcing us to find indirect ways to understand what lies beneath. And just when it starts to feel like everything is locked away, sealed beneath that immense barrier of ice, as if Europa is a closed system that will never truly reveal itself, something changes. Not in a dramatic explosion or an obvious rupture, but in a way that is far more subtle and, in some sense, far more important. Because it suggests that the boundary between the surface and the ocean is not as absolute as it first appears. For a long time, the assumption was simple and almost discouraging, which is that if the ocean lies beneath tens of kilometers of ice, then accessing it directly would require technology far beyond our current capabilities, meaning that whatever exists down there would remain hidden for the foreseeable future. But science has a way of advancing not just through new missions, but through new interpretations of old data. And Europa is a perfect example of that. Because the first real hint that the ocean might not be completely isolated came not as a clear confirmation, but as something that could easily have been overlooked. In 2012, observations from the Hubble Space Telescope revealed what appeared to be faint plumes of water vapor rising from Europa's surface, reaching hundreds of kilometers into space before dissipating into the vacuum. At the time, the evidence was tentative, because detecting such features at that distance is extremely challenging. And the signal was subtle enough that it required careful analysis to even suggest that something unusual was happening. But the idea was compelling, because if those plumes were real, they would represent a direct pathway from the ocean to space. A mechanism by which material from deep below could escape the ice shell without requiring it to be broken open entirely. And then came the realization that something like this might have already been observed when scientists revisited data from the Galileo spacecraft, specifically from a close flyby in 1997. They found patterns that had gone unexplained for decades, including sudden changes in the magnetic field and spikes in plasma density that did not fit any simple model of Europa's environment at the time. When these anomalies were re-examined with the plume hypothesis in mind, a new interpretation emerged, one that suggested Galileo may have passed directly through a column of water vapor erupting from the surface, effectively sampling material from Europa's interior without even knowing it. That changes everything in a way that is easy to underestimate. Because if these plumes are real, and multiple lines of evidence now suggest that they are, then Europa is not a completely sealed world. It is not perfectly isolated from its own ocean. Instead, it behaves more like a system under pressure, occasionally releasing material through fractures or weak nikat in the ice, allowing water and dissolved chemicals to escape into space in intermittent bursts. The ocean is not just sitting there in silence. It is interacting with its surroundings, however, indirectly. And that interaction creates an opportunity that did not exist before. Instead of drilling through kilometers of ice, instead of landing on a surface that is constantly bombarded by radiation, a spacecraft could simply fly through one of these plumes, passing through a cloud of vapor and microscopic droplets that originated from deep within the ocean. Those particles would carry information, chemical signatures, traces of whatever processes are occurring below, effectively turning Europa into a place that offers samples of its own interior without requiring us to break through its outer shell. And that possibility transforms the problem from one of inaccessibility into one of timing and observation. Because now the challenge is not how to reach the ocean, but how to intercept what the ocean is already sending out. How to be in the right place at the right time when a plume erupts, and how to analyze its composition with enough precision to detect even the faintest sanket of complex chemistry. It is a completely different approach, one that relies on the natural behavior of the moon rather than forcing an artificial pathway into it. But there is another layer to this, something that goes beyond the practical advantages of plume sampling and into a deeper understanding of Europa as a system. If material from the ocean can reach the surface and escape into space, then the ocean is not isolated in the absolute sense. It is connected, even if that connection is sporadic, even if it occurs through narrow channels or transient gatnaya. There is movement. There is exchange. There is a pathway, however limited, between the hidden interior and the outer environment. And that means something important, something that brings us back to the question that has been quietly building throughout this entire discussion. If there is chemistry happening in that ocean, if there are processes unfolding over long time scales, then they may not be entirely confined to the depths. They may leave traces, signatures carried upward through the ice and released into space, waiting to be detected by instruments that are sensitive enough to recognize them. The silence of that ocean, in other words, may not be complete. It may be speaking in a language we are only just beginning to understand. So when you think about Europa now, I don't want you to imagine it as a locked box anymore, something sealed and unreachable. I want you to imagine it as a system that occasionally opens itself, briefly, unpredictably, releasing pieces of its hidden world into the vacuum, offering us a chance to study what lies beneath without ever having to descend through the ice. And all we have to do is be ready to listen when it does. So now we arrive at the question that has been sitting quietly behind everything we have explored so far. Not stated directly at first, but growing more unavoidable with each piece of evidence. Each layer we peel back. And I want you to approach it carefully, not with assumptions or imagination running ahead of the facts, but with the same disciplined curiosity that got us here in the first place. Because this question is simple in form, but profound in its implications. Could something actually be alive in that ocean beneath the ice? To answer that, we have to strip the idea of life down to its most basic requirements. Not what we are familiar with, not what we see on the surface of Earth, but what is fundamentally necessary for any system to qualify as living in a scientific sense. First, you need liquid water, because all known life depends on it as a medium for chemistry. And on this point, Europa is not just sufficient, It is abundant beyond expectation, with an ocean that may contain more water than all of Earth's oceans combined, stable over immense spans of time, protected from the harshness of space by the thick ice above. Second, you need the right chemical ingredients, elements like carbon, hydrogen, oxygen, nitrogen, and sulfur, the building blocks that allow complex molecules to form, interact, and eventually organize into something that can replicate and evolve. The evidence we have suggests that Europa likely possesses many of these elements, especially now that observations have confirmed the presence of carbon dioxide associated with material originating from the interior, which implies that the ocean itself is not chemically empty, but part of a system where meaningful reactions can occur. But then we reach the third requirement, and this is where the uncertainty becomes much more serious. Because life does not just need water and ingredients. It needs energy, a continuous source that can drive chemical reactions and maintain order against the natural tendency toward disorder. On Earth, that energy often comes from sunlight, but we already know that Europa's ocean exists in complete darkness, completely cut off from solar radiation by kilometers of ice, which means any life that exists there would have to rely on a different kind of energy source. At this point, it is tempting to look at Earth for analogies, because our own planet provides examples of life in environments that seem, at first glance, just as extreme. Deep in Earth's oceans, far from sunlight, there are hydrothermal vents where water interacts with hot rock, releasing mineral-rich fluids and chemical energy into the surrounding environment. Entire ecosystems thrive in these locations, supported not by light, but by chemical reactions, where microorganisms use compounds like hydrogen sulfide as an energy source and form the base of a complex food web. So naturally, you might expect something similar on Europa, a seafloor with active hydrothermal vents providing energy for life. But this is where the situation becomes more complicated, because recent studies suggest that Europa's interior may not be as geologically active as Earth's in the way that matters for those kinds of systems. The rocky mantle beneath the ocean may not produce enough heat to sustain widespread volcanic activity. And simulations indicate that magma may not be able to reach the ocean floor efficiently. Without active volcanism, one of the most powerful sources of chemical energy disappears, and that removes one of the most straightforward pathways for life to exist. However, the story does not end there, because there is another process that does not rely on high temperatures or active volcanoes, but can still generate energy in a way that is relevant to biology. This process is called serpentinization, and it occurs when water interacts with certain types of rock, triggering chemical reactions that produce hydrogen gas and release heat even at relatively low temperatures. That hydrogen can then serve as a potential energy source for microbial life, similar to what we see in some environments on Earth. What makes this important is that serpentinization can operate over long periods of time without requiring extreme conditions, meaning that even a relatively quiet interior could still support a steady supply of chemical energy. Some models suggest that this kind of system could persist for billions of years, providing a stable environment where life could emerge slowly and sustain itself without ever needing sunlight or dramatic geological activity. So now you are left with a picture that is neither clearly promising nor clearly discouraging, but balanced in a way that forces you to consider both possibilities at the same time. Europa appears to have water. It likely has the necessary chemical ingredients, and it may have a viable source of energy. But each of these factors comes with uncertainty, with limits, with conditions that may or may not be sufficient when combined And that is where the tension lies. Because if even the minimum requirements are met, even barely, then life could exist in that ocean, perhaps simple, perhaps microbial, but real, evolving in complete isolation from the rest of the solar system. But if the energy is too limited, if the chemistry is not diverse enough, or if the environment is too stable to drive complexity, then the ocean could remain completely sterile, a vast, dark reservoir of water with all the ingredients for life, but none of the processes needed to bring it into existence. So when you ask whether something could be alive down there, the honest answer is not a confident yes or a definitive no, but something much more uncertain and, in a way, much more compelling. Europa sits right at the boundary between possibility and emptiness, between a world that could quietly host life and one that remains entirely lifeless. And until we gather direct evidence, we are left in that space of uncertainty, knowing that either answer would change the way we understand life in the universe. Right now, as you are listening to this, something we built is already on its way there, moving silently through space with a purpose that is both precise and strangely personal. Because even though it is a machine, even though it carries instruments instead of thoughts, it represents a question that comes from us, from the same curiosity that made you imagine descending into that ocean in the first place. That mission is Europa Clipper. And it is not traveling to Europa just to observe it from a distance, but to confront the uncertainty that has been building throughout everything we have explored. When it arrives at Jupiter, it will not land, and it will not attempt to drill through the ice, because we already understand how difficult and risky that would be, especially in an environment flooded with radiation strong enough to damage even hardened electronics. Instead, it will take a different approach, one that depends on everything we have learned about Europa's structure and behavior. And that approach is repeated close flybys, passing near the surface again and again, mapping the ice, measuring its thickness, analyzing its composition, and most importantly, searching for those plumes, those brief moments when the hidden ocean reaches out into space. If those plumes are active when Europa Clipper passes through them, its instruments will be able to analyze the material directly, detecting molecules, identifying chemical patterns, and possibly finding hints of complex organic compounds. This is not the same as landing in the ocean, but in a way it is more elegant, because it allows us to study the interior without breaking through the barrier that has protected it for billions of years. It is like listening to a distant world speak in fragments, catching pieces of its story as they drift past. And this is where the question becomes larger than Europa itself, because what we find or do not find will not stay confined to that moon. If Europa's ocean turns out to be completely barren, if all that water, all that time, all that potential leads to nothing, then we are forced to confront a possibility that is deeply uncomfortable, which is that life may be far rarer than we hope, that even when the basic conditions seem to be present, something more is required, something subtle and difficult to reproduce. It would mean that Earth is not just a place where life exists, but a place where something unlikely happened, something that may not occur easily elsewhere. But if we find even the simplest form of life, even a single-celled organism using chemical energy in the dark, then the implication is just as profound, but in the opposite direction. It would mean that life is not a rare accident, not a singular event tied to a unique set of circumstances, but a process that emerges whenever the conditions are right, even in places without sunlight, even in environments completely cut off from what we consider familiar, it would mean that the universe is not silent in the way we once thought, but filled with possibilities, with worlds that may host life in forms we are only beginning to imagine. And I want you to notice something important here, because in both cases, whether we find life or not, the answer is not neutral. There is no version of this where nothing changes. Either we learn that life is extraordinarily rare, and that carries its own weight, its own sense of isolation, or we learn that life can emerge more than once, even within a single solar system, and that opens a door that cannot easily be closed again. Because if it happened on Earth and on Europa, then there is no reason to think it has not happened elsewhere, on countless other worlds scattered across the galaxy. So when you think about Europa now, I don't want you to see it as just another moon orbiting a giant planet. I want you to see it as a test, not of technology, but of an idea. The idea that life is either a rare exception or a common outcome. Beneath that ice, in that ocean you imagined at the beginning, there may be nothing at all, just water and chemistry playing out in silence. Or there may be something small, something simple, something alive, carrying on a process that began independently of Earth. And somewhere between now and the moment Europa Clipper begins sending back its data, that uncertainty will start to collapse into an answer. Until then, that ocean remains what it has always been, a hidden world, sealed beneath ice, shaped by forces we can measure but not directly touch, holding a question that extends far beyond itself. And whatever is down there, whether it is life or emptiness, has been waiting in the dark for billions of years, long before we had the ability to ask about it. And now, for the first time, we are finally close enough to listen.